I want to show you the setup I've been using for complex audio inputs inside many of my Resolume plugins. So what I've essentially done is create an FFT template for Resolume Wire. This takes a Spectrum in node and basically splits it into many different audio components, much like you would see in synesthesia. That was definitely one of my primary inspirations for this project. So let's pull it up here. You can see right now there is no audio coming into the Spectrum in. So let's go ahead over here and change our Spectrum in setting to external. That is what my FFT is set to. So we changed that to external, and now you can see that all of the parameters are jumping around to the sound of my voice. We have our levels, our presence, our hits, and time-like variables that grow at different rates depending on the input from that part of the spectrum. So now let's go ahead and jump into Resolume Wire, and I can explain a little bit what's going on under the hood and how you can use this in your own project. So here you can see all of the modules associated with our FFT template. Before I go through and explain what each one is, I just wanted to make a note. Resolume Wire does not currently allow you to do audio input. So if you're going to be working on a patch that uses audio, I would highly suggest having Arena open or Avenue or whatever at the same time so that you can check how those audio inputs are affecting your patch. All right, so to dive right in here, our base module is the only one that's required out of everything. Everything builds off of this as it takes our spectrum in and splits it into multiple different parts of that spectrum. You know, our bass, our mids, our mid-highs, our highs. So if you're going to be using only parts of this template, make sure you have that bass added as well. So to go through each of these modules, our hits are going to be, you can see over here, our hits are the basically like the snare hits or the fleeting pipes, the fleeting peaks in our spectrum levels. So this is great for stuff like strobes or any sort of rapid rise and fall in action. I use these a lot for complex timers. I'll get to that in the next part of this video. But moving on, we have our presence, which is like our large feature detection. That is basically going to be checking how full those parts of the spectrum are over time, about 3 seconds if you're looking at these envelope followers. So that's great for, you know, large scale lighting, camera movements, anything that's large and dramatic, as this will follow the scene as the levels come and go. It kind of just smooths those levels out over time. And so if we move up here, you can see we also have the levels, which is a much shorter duration. And that'll give you a more traditional look when it comes to those levels that are bouncing up and down to the audio. Moving up here, we have the time since last frame, which is not exactly a time variable or an audio variable rather. But I think it was important to include, as this gives us basically the amount of time in seconds that's elapsed since the previous render. And this is great for creating smooth timers. It's essentially just, you know, giving us a delta on our time as we've rendered. But this is another one I include with many different timers and things like that, as it can give us just smooth numbers over time, and it's easier to control than, say, the raw transport time or whatever. So moving on to here, we have our beat features, which some of this is already built into Resolume, but I kind of wanted to expose all of it together just out of convenience. Things like our BPM and our beat time, that's just built into Resolume. But some of the other things like the beat phase, that'll give you a 0 to 1 based on how far into that beat we are. The BPM twitcher is like it's a time variable that increments as the BPM goes higher. So it's a time variable that basically jumps with the beat. The BPM sine is fairly self-explanatory. That's just a 0 to 1 sine wave. Random on beat, trigger on beat, toggle on beat, all very self-explanatory. So moving down here, our FFT textures are like the traditional spectrum inputs you would imagine. You can see here at the bottom of our audio visualizer shader I have included, it's just a spectrum texture, a one-dimensional spectrum texture that gives you a value between 0 and 1 based on how deep into the spectrum we are. And each band of the spectrum gets its own textures, so that's great if you want to do more, traditional audio visualizers, or if you need to include the spectrum as a texture, maybe as lighting on the side of a ray march or something like that. And then finally, to conclude, we have our time variables. And so included in here, you can see I have the raw system time. That's just going to be our number of seconds since the start of the patch. So using that concept, if we look at the other time variables, these timers are going to increase at the same rate as that system time, but they'll also increase faster if the presence of that part of the spectrum is higher. So these are great for doing, really complex animations, sine waves, whatever, because you can highlight different parts of the spectrum, and as that audio moves, you'll get different interactions based on those different parts of the spectrum. So this is a really powerful one that I use in pretty much every single shader of mine. So yeah, that's the entire patch. I would highly recommend that you just go through and tinker with these outputs in your own work and see what works best for you. If you have any questions or comments, I'd be more than happy to answer anything. And this will be up on my Patreon for all subscribers, and I'm looking forward to what you guys make with it. So definitely let me know. And yeah, I'll put out a second video soon with pretty much how I use this template and some of the complex interactions you can get into with the audio FFT spectrum in Resolume.